Swayam Prabha. Digital India. Educated India.
Nice to see bright young faces. So, you all know what is the topic of today, right? You have already gone through lectures in other fields of civil engineering. Today and tomorrow I will be talking to you about environmental engineering, right? It is not a new topic to you. Maybe the other topics were new to you. It was now you were not exposed to it in your school, right? But environment is something which is introduced to you right from your kindergarten or first year, right. So, it is nothing new to you, but what I would like to expose you is to the domain of the vast domain of environment and how as engineers, right, we can play a role in controlling the way things are happening and mitigating the damage which human impact is causing the environment and make the environment better for now and for the future generations. Okay. So, the engineering aspect was what was missing in your school education probably. All of you are almost exposed to environment subject, right. The impacts, it has been hammered on to us not only in school, but in social media, in print media. I am sure everybody is now quite aware in the recent trends, recent times, a lot of awareness has been generated in multiple media. Okay, so let me quickly get into the subject. So, environment, as you see here, is everything including us, right. In Sanskrit we call it the Panchabhutam, and you can add other dimensions to the same Panchabhutam principle, right. Everything around us, water, air, soil, materials, that is the one which I added, okay, and energy, right. Everything includes environment, including us, and we are in the center of everything. I mean it is not just humans, I should have also included the whole living system, okay, which is controlled and which controls all these 5 dimensions. Okay. So, it is important to understand each of these domains separately and also to understand the interactions between the human and the living ecosystem with these 5 different domains. Okay. Water, as we all know, is very important, right. Water can be comes from various sources, comes in various forms, right. And I think nowadays this summer everybody has realized, even those who did not realize the importance of water has been made to realize by nature, right, all across the country. And we are also seeing it across the world, in parts of the world where water supply is in kind of not equitable distribution of, I will not say it is limited, but it is not equitably distributed across the boundaries and across the annual time frame. That is why we face water shortages. Okay. So, water comes from surface water, groundwater, we all know this, glaciers, okay, but I would like to show, and sea water, predominantly 4 different sources, and you can see that what the quantum of water which we have access, okay, is very small. So, although we have a lot of water, if you look at the globe, you have a lot of water, but all the water in earth, okay, is about 97% of the water is saline, only 3% is fresh water, right. So, and in that 3% we have only about 30% accessible to us in terms as water, the rest of them are all glaciers or ice caps on mountains, okay. And in that quantum of surface water and fresh water which is available to us, you can see the distribution that most of it ends up, the surface water particularly, is in the lakes, right. We all have seen lakes, rivers, but we really don't know how much is available where. Okay, this kind of puts things into perspective, and it also helps us to understand which component of the water which we have to value and which we have to protect, okay, depending upon the quantum. So, lakes seem to be the dominant surface water source, whether we know it or not, and we all know what is the pathetic state of lakes, right, in any urban system. Okay. So, somewhere along the line people did not probably pay attention to all this, and some mismanagement has happened, and we need to put things back into the right spot, okay, and in the right condition. Next thing is air, right. Air has, we all know, different layers. I do not want to go into the details, but the most important layer which human interacts, or where humans have an impact, is troposphere and stratosphere. Okay. Troposphere very close to where we live and a few kilometers above. And what has happened to the troposphere over the last few, I would say, decades still, right, not centuries. Okay. All the damage has happened within the last century, right. So, what this kind of gives you an overall perspective of what is happening to the air environment, which is very, very important, right. If you put an order of priority, air comes first to humans or any living system, okay, then water, then food, and then shelter. Okay. So, we are touching upon, in environmental engineering we touch upon all these important aspects of human sustenance, or in larger perspective the ecosystem, sustenance of the living things in the ecosystem. Okay. So, air pollution comes from multiple sources, right. I wish this was more interactive, I could have got the answers from you, but I am just, I have listed everything, the slide kind of lists everything here. It can be man-made, mostly man-made impacts to the air coming from transportation, our daily travel, okay, in vehicles create a lot of pollution. Then we also have our industries which contribute a major source of pollution, okay, industries emitting all these toxic fumes during their manufacturing process. And then we have our energy sources. Energy sources are like thermal power plants. India is still dependent on, a large percentage of energy comes from thermal power plants, and I hope you all know they are the biggest, and they create the biggest environmental impact, not just by using coal or sometimes fuel oil, that itself is a big impact. The emissions are a very big impact, and also the water. Do you know how thermal power plants impact the water environment? There is always relations, I told you, right, human and these 5 domains, and the 5 domains impacting the human. Not only that, there is also a interconnection between these, among these 5 domains, right. So, how air or energy domain impacts the water domain? Exactly, when we have thermal power plants, one big impact is not only the contamination, but also the temperature contamination, like thermal contamination we call them. You cannot just release the hot water from the thermal power plant directly into a water body. It completely damages the ecosystem there, right, from corals to plants, planktons, the basic life forms, to fishes. Okay. So, it has a huge impact, and not only that, it consumes a lot of water in the first place, right. The largest, if you look at, rank all the industries, okay, and look at their water footprint, you will find that thermal power plants are on the top of the list, right. Many of us do not know this. Okay. Thermal power plants consume a huge amount of water in terms of cooling water. Okay. So, it impacts air, energy domain impacts air, it also impacts water, okay, and together they all impact the living ecosystem. Okay. So, we had human related pollution like your transportation, I talked about energy and other industries. We also have the most necessity, we may think that agriculture is the most benign way of benign industry, right. So, agriculture also has a huge impact on the other domains of environment like air and water primarily and soil, right, because of usage we become more, as agriculture becomes more intensive, we use more water, we use more fertilizers, we use more pesticides, okay. It does, as we move away from nature, it has an impact on the nature, okay. So, agriculture, then also natural, right. There are natural things which are happening for which we have no control, right. There is even the formation of ozone, NOx, right. The NOx combines with CFCs, okay, to create all these impacts, okay, which can affect the ozone layer. Okay. Certain things we have control, certain things we do not have control, okay. But it was in a balance. When we have volcanoes or wildfires, a lot of emissions are happening, right, but it was nullified by the nature's capacity to heal itself, okay. The issues come only when nature, when we exceed the capacity of nature to heal itself, okay. Yeah, so troposphere, lot of these things what we discuss is only impacting the troposphere, and that is the zone where we are closely related in, but we also have this whole ozone layer, hole in the ozone layer which has been talked about a lot, okay. So, the UV radiations can penetrate if there is a hole, and then there is a lot of impacts on skin and other body conditions for humans, okay. So, ozone layer has been severely impacted because of human interventions, okay. So, can you name one compound which impacts ozone layer? CFCs, yeah, we have heard a lot about this, okay. But what is the good news? You can see in the picture how the UV radiations are filtered by ozone layer, which does not happen when there is a hole, right. And the hole has been mostly found in the extremes of our earth, Arctic, Antarctic. And what is happening? Good news, what is the good news in recent times? The picture also shows you that ozone hole, because, okay, I also want to talk about the positive things which people and community, scientists, environmental engineers have brought about, okay. Together, okay, there was a huge awareness created in the entire, in the global, the scientists have created a huge awareness program, and they have worked on alternatives, okay. So, alternatives to CFCs. CFCs are banned, okay, over the last decade. Many countries have now adopted that, and they are very serious, and so what is happening? The hole is shrinking, okay. So, the positive thing is, many times you will only hear negative things about environmental damage, environmental pollution, man development is causing this. So, we cannot shut down development, right. We cannot live without energy, all of us need energy, nice air conditioned room here, right. So, where does all the energy come from? Thermal power plants, right. So, can we just have it in an open environment, natural environment, go back to Gurukul, right, no chairs, sit under the tree? Is it possible nowadays? We need a lot of gadgets in education, in our day-to-day life, okay. So, we need a lot of energy, we need a lot of materials, right. We cannot live without all that now. We cannot reverse the time clock and go back, right. So, how do we do it? With balancing it with the environment, and if we make a mistake, it's very, very common that we make a mistake, right. If you look at stories of environmental degradation, it has always been a mistake. Some things which were thought were right, okay. Few decades later they realized that it's the wrong way to go, and then it's okay, right. At that point of time our knowledge was limited, okay. We learned a lot, okay, over the last few decades, okay. So, if it is possible to reverse it, it is okay, okay. We don't really have to beat ourselves up saying that we did a really terrible thing. It's okay as long as we can recoup and we don't have permanent damage, okay, it is fine. So, ozone hole closure is one big achievement with collectively mankind and technology okay, have science and engineering put together, everything made that happen, okay, government, policy, okay, industries, everybody came together, realized it's a problem, and now what is, that's a good news. So what is the other problem which humanity is facing, environment is facing, which needs this kind of an intervention or which is already happening? Can you think of something which everybody in the world is talking about? Global warming, right? So that's much more threatening, okay, because it threatens everything, the existence of everything in this world, okay, and it's connected again to all these domains, water, they say drought and flood and diseases and everything is related to global warming, okay. So that needs a much more bigger attention and sooner, okay, the attention has to be sooner. The clock is ticking, that's what the people who are working in climate change and global warming keep telling and putting pressure, okay, and many of that damage is irreversible, that's the worst case, okay. So coming back, the third domain which I want to talk about is the soil domain. You might have heard about soil with a different angle from the geotechnical faculty. Is it already done, this class? No, okay, you will be hearing soon, okay. So soil has multiple dimensions. To civil engineers, geotechnical is one dimension where we look at foundations, right, that's we look at the building has to have a foundation, and we try to understand how soil can take the load, okay, different types of soil, how their capacity to take the load, how do we engineer structures, okay, so that they can be anchored into soil, okay. So the engineering comes in because man wants a certain thing or a certain building of certain size in a certain place, right. If the soil is not good, what do? We re-engineer the soil, right. So our technology has improved so much that we could do all that and make things happen, right. That's what civil engineers do. We don't compromise, right. So engineering has given us the strength to do all that, okay. Again, agriculture is one domain where soil is very closely connected to us, right. Soil is the basis for growing food crops, right. And groundwater, that is also closely connected to soil, right. Groundwater is in the soil, right. It's not separate, it's just the pore spaces of the soil is where the groundwater is stored, right. And also soil is important to us when we go off to finally dispose things, including ourselves, our own physical self, right. And now of late, lot of wastewater, everything is being disposed in the soil, okay. So that is where problems occur, okay. So how do we do this disposal practices and how it has impacted? So some examples you see here, okay. How do we avoid this? How do we do disposal in a safe manner? We still can dispose, but it has to be in an engineered landfill, right. Many countries have engineered landfills. India is still yet to make even that small step when it comes to waste disposal, okay. And there are also in environmental engineering, you will learn about not only the contamination problem, soil contamination, groundwater contamination. Because of soil contamination, you also get groundwater contamination, because when water falls, it percolates through a contaminated soil, then your groundwater is going to be contaminated, okay. Or it can, contaminated soil can also contaminate surface water, because everything runoff ends up in rivers and lakes, right. So we need to understand how soil contamination has happened, what is the extent, okay, and how to reverse things if it has already happened, and even before that we should know how to avoid. If it has already happened, we should know how to reverse it, okay, or how do we safely dispose things, okay. Even nuclear remains, right, waste are buried very deep into the soil, right. So we need to be very careful how we do that, okay, because some of those are completely irreversible and the impact is going to be long term, okay. So engineering, environmental engineering, you learn about the interactions of wastewater chemicals with soil and groundwater, and also remediation practices. Okay. And also I wanted to see, just throw some light on again the interactions. Okay. So I told you about soil contamination impacting groundwater. Do you know what happens when, how can groundwater impact soil strength? Have you heard of cases where groundwater is abstracted extensively, large quantum of groundwater? That's what is happening in Chennai now, because we are dried on rivers and lakes, so we keep abstracting a lot of groundwater. Okay, what does that do to the soil? You might not have heard about this. If somebody has heard, it's fine. Okay, ground subsidence happens when there is huge abstraction in one particular area. Depending on the soil condition, sinkholes have been formed. Okay, entire buildings have collapsed. Okay, because they were abstracting a lot of groundwaters. Okay, so you learn, there is a close interaction between what you learn in your geotech and environmental engineering in these domains. And also when I talked about landfill, okay, we need, so the whole domain is called geo-environmental engineering, right? We have a lot of faculty working in that domain. Okay, that's where geotech and environment come together. Next, energy, a very, very important topic, right? We already touched upon energy, we have read about all this. There are sources of renewable energy, non-renewable energy, and everybody has been talking about moving from that side to this side, okay, or how fast is it happening? We keep talking. Environment is something which everybody talks about. Have you heard about it or seen it, right? Everybody talks about it. You need not be an environmental engineer, right? Even the roadside person to politicians. But the sad thing is only talking happens, right? Not much action. When it comes to action, you see a slowdown, okay? So this talk also has been happening for a long time, renewable to non-renewable, non-renewable to renewable, and India is making some progress. But then as young engineers who are going to get into this field, you should understand the whole thing holistically, right? How good is a technology? You can just see like solar, everybody is promoting solar, right? And windmills, of course it is a good, instead of oil or coal, it's good to have these, okay? But what is the environment footprint of these non-renewable sources of energy? Sorry, renewable sources of energy, okay? Do you see any environmental impact of these? EV, everybody talks about EV, right? That's a trending thing. Okay, EV is good. That's what people keep promoting. Okay, any thoughts? You need to reflect on, we need to see where these materials come from. Okay, many times in environmental engineering and even in other fields, we have blindly tried to copy what people in the West, because they started thinking first, they found certain things suitable to their country and their eco conditions, okay, but may not be the same for us. Okay. In environmental engineering, when you come to your second year, you will be learning about different treatment technologies. Okay. Most of the treatment technologies are huge energy guzzlers. Okay. Activated sludge process. I think you will be visiting as part of the class to our sewage treatment plant. Okay, in IIT, it's one of the best, okay, but it's a huge energy guzzler, okay. Many places where there is no energy also, they have these technology, okay. What will happen when you have an energy guzzler and we don't have adequate power? What will they do? They will not run the plant, right? They may build the plant, but they may not run the plant. Okay, because they may not even have power for operating the industrial processes. Why would they operate the treatment plant, okay, when there are ways to get away with it? Okay, so there are technology, you have to look at all the options. There are non-energy or low energy technology options for doing the same thing, right? Many times we don't look at the options. Okay, so similarly, when we talk about solar, wind, and EV, they are good, I am not denying, okay. But what is the cost to the environment when we are building these, okay, particularly if we do not have lithium resource in our country, right, what is going to happen? Solar, again, it is now being completely imported from China, right, we do not have the basic material to build these solar panels. What makes our, what we will become totally dependent on certain countries, and certain other countries will be, as we become more and more dependent on these sources, we will become more and more controlled by these countries, right. So, it is not just engineering alone, okay, you need to think beyond all that, okay, and see what is suitable for our country for sustained approach, okay, and self-reliant approach, okay. So, if anybody gives you an option, just do not take it, okay, it is just like marketing, somebody marketing a product to you, okay, weigh all the pros and cons, long term, short term, okay. So, that is what I want to talk about renewable energy. There is something called life cycle assessment which you will learn as you go along, okay. So, life cycle assessment gives you an entire holistic picture about any product, whether it is a thermal power plant or it is a small cell phone or a pen, okay, where the materials come from and where, okay, what is the energy input, okay, we need to look at things holistically, it is a little too much for you now. So, just be aware that, okay, everything has pros and cons, okay, and we need to be always conscious about what is the impact to environment when we make a choice. The most important topic, okay, as civil engineers or as engineers, any engineer should know this, is this particular domain, materials, right. What do you mean by materials? This is again a topic which is common to all engineering fields, not just material person, okay, or a metallurgy, materials and metallurgy engineers. So, as civil engineers, we deal with a lot of materials, cement, concrete, sand, gravel, steel, and all these new composite materials, okay, including polymers, okay. So, we always we have to make choices as you are embarking into civil engineering, right. The traditional approach is concrete, steel, right, masonry. You will be learning all the conventional materials and you will also be exposed to new materials, okay. And now the whole world is going towards becoming a green world, right, green buildings, okay. It's not just greening the buildings, but looking at choice of materials. It is not just making the air conditioning less or water conservation and all that, but fundamentally as civil engineers, we should be able to make the right choice of material. Each material has a carbon footprint, as a water footprint, right. So, you can, now that technology has given us so much options to choose from, right from your wall panel to your door, okay, to the table where you are sitting, you have a lot of options, okay. We often go with the option of how good it looks, right, how fancy it is, what is trending, even when you are choosing a cell phone, okay. Have we ever thought how safe it is for the environment when they manufacture this product, right? What is the impact of this product? And then made your choice based on that. Many people are doing it, okay. If you are equipped with the right tools, right, now you have that green dot for organic food or vegetarian food and all that, and now you make a choice. Even a year earlier, it was not there in India, right. So, if you are given a choice and if you are given a data about a product, whoever is conscious, okay, can make a choice, and that is what the life cycle assessment and sustainability classes teach you. You can make conscious decision about the product you choose to use, okay. So, I have just listed all the materials which we are working with, and so this kind of gives you a very large perspective of where we were and where we are in terms of material dependence and material usage, okay. From the food we eat, the material which goes into making it, food, shelter, clothing, basic essentials of life to the luxuries of life, right. That is what I had captured in this, okay. From essentials to luxury, there is so much of materials, different types of, at least I can think of about 50 different materials which are mined and used for our everyday use, okay, even essentials. So, this is a very nice picture. You may not be able to see the details of it, but when it is shared to you, you can see that it captures all the different materials which human use, right. Starting, and its timeline is also given, starting from BC, 100,000 years BC to current days, okay. When materials started coming into existence in the human domain and how the change has happened over a timeline, okay. It is very important for engineers, particularly civil engineers, to see that red line, okay. So, earlier we were completely dependent on renewable sources of materials when we were, like I said, Gurukul times, okay. Obviously, we cannot do that now, okay, but the scary part is we did not have a balance, right. Where are we now? As the timeline shifted, okay, from Stone Age to Copper Age, Bronze Age, Iron Age, Age of Steel, Age of Polymers, and now we are in, they say, molecular age, where all these path breaking things are happening, okay, the nano or the molecular age. What has happened now? What does the arrow indicate? From total dependence on renewables to total dependence on non-renewables, okay, that is scary, right, because non-renewables are non-renewables, right. What will happen if we are exhausting it? Already we have gone in that path, okay. So, how do we engineer and build things and build products which can have a balance between the two, and how do we reverse things, okay. And we know that people have given these scary numbers. The earth holding capacity of the earth is like, we have exceeded it by 1.5 times, okay. Every year you will see that there is a day when alarm bells ring and say that this day you have exhausted your quota. Everybody has a quota. What is that quota? Carrying capacity of the earth or the replenishing capacity of the earth, okay. It was usually like, now it moved from 70s, this has been happening, okay. We are now using 1.5 times the material in the earth. That means we are utilizing, or we are utilizing more than what the earth can replenish, 1.5 times, 50% exceedance, okay. And the time is shifting. I think this year it was August. In August we have utilized, okay, what is our quota, and all the rest of the months it is, we are taking from future generation, right. So, you have to go and see, I can send you links, okay. These are scary things we need to really worry about and think about, okay. And not only worry and think, but how do we reverse it? And it is easy, you just have to consciously do certain things, okay. Yeah, this is a chart which talks about what is a major group of materials which we are all consuming, okay. It's surprising, isn't it? What you thought might have been different. Ceramics are often dominated by concrete, okay. That is the material which we are using the maximum, and it has the largest carbon footprint. Cement manufacturing, okay, bricks, they all have the steel, they all have a very large carbon footprint and water footprint. I hope you all understand what is carbon footprint and water footprint, right. How amount of carbon dioxide emitted from mining to processing, and when it comes to a final form. Similarly, how much water we have utilized, okay. These have to be made a note of when we are making some choices. Can we find alternatives, okay, which are less, which have a less water footprint and carbon footprint, okay. And what future holds? Not the way in which we are going, okay. Without this conscious decisions, okay, is disastrous, okay. The resource, as you see there, is being utilized at an exponential rate, and look at the population. It is not exponential, it is even much more. It is called explosive growth in population, okay. The doubling time has been reduced, doubling time of population, okay. In terms of years you can see, okay, it's getting shorter and shorter. That means the population is growing, and for all this population we need to have, they all have this demand. The demand is also growing, right? Per capita demand is growing. People are becoming more and more towards luxury items, okay, without the consciousness, okay. But it's not bad, but we have to do it in a balanced way, okay. We need to think whether we really need what we want, okay. Yeah, so we talked about carbon footprint, water footprint, ecological footprint, okay, which combines the capacity of the earth to replenish. And the threat of climate change is real. For a long time people were debating, but then it is real, okay. There is no more debate about it, even though the top leaders still have some doubts in their mind, okay. We cannot afford to have that doubt. You people cannot afford to have that doubt. You are the future generation, okay. So, yes, just want to put things in perspective. Although these things are talked about and action has been done by multiple people in other domains, as civil engineers, you have a big role to play, okay. Whatever domain you choose, structures, building technology or transportation, whatever domain of civil engineering you choose to specialize or you become interested in, environment consciousness should be there in the top of your mind. And obviously if you are going to choose environmental engineering or water resources, you have even better, you will get even closer to the subject and you will be understanding all that nuts and bolts of how to, okay, reverse things, okay. Primarily that is what you will be learning in your environmental engineering, okay. Yeah, I have just listed waste management is one domain area where we can do a lot, because it is in India, it is just starting. We have not even done anything yet, okay. There is so much to do and there are so much opportunities in that domain. And this new 6R, I do not know if you know about 3 R's, many people know, reduce, reuse, recycle. 6R is a new concept, okay. 6R starts from rethink and reinvent, okay. That is what I have been telling you. Even before you make a product, do not think about at the waste end reusing and recycling, but think when you are developing a product, when you are designing a product, okay. What materials to go, can we do it differently, can the process be different, so it has a reduced carbon footprint and water footprint. So it starts from there, reinvent, rethink, refuse, okay. Certain things, if you do not want, if you do not need, you can refuse. Something like people give you when you go to a birthday party, they give you some gift, right, take home gift. What do they call it? Return gift. Most of the things are junk in return gift, and it goes straight to your dustbin, or you just keep it there for the sake of people have given you, and then one day you just discard it, right. So refuse things which you do not want, so that you do not generate waste. And then all that we already know, reduce, refurbish, repair, build things to last, okay, right from buildings, okay. Those days the temples lasted for thousands, even now they are there, right, thousands of years, okay. But we do not build buildings that can last for more than 50 years, okay. So that's, the entire waste is just going to be there when you demolish a building and build another one, okay. Right from buildings to cell phones to pens. How many of you buy a refill and put it in your pen? I am glad there are few hands going up. Ask for a refill. Many times even the shops do not carry refills, right, until we find even that refill has not very sustainable. Ink pen may be the best, but convenience sake we need to have a compromise, right. So do something at your own personal level. There are certain things which we can do at a personal level, as an engineer, as a civil engineer, as an environmental engineer, okay, or when you go and take up big positions as administrative officers, IAS, IES, okay, or a politician, okay. There are multiple ways in which you can contribute, but we will start doing it when we have control, where we have control, okay. So I think we are almost there, 8:51. I just want to, that's where my talk is going to end, But these are some of the things I wanted to tell you, that as an environmental engineer, you will be working in all domains, okay, chemistry, geology, physics, whichever, you always have something to learn from other domains. And it is also interactive between different domains of engineering, chemical engineering, mechanics, we work with all these domain areas. So if you have missed out being a computer science graduate, you still can do hi-fi modeling when it comes to climate science and other things, okay. Material, biotech, we interact with all these domains, okay. And your work environment can be from a lab to an office to even Arctic. Environmental engineers go into space missions, Arctic, Antarctic, okay. And the whole world is your lab. You can go out, most of our students are always outside, okay, working in lakes, rivers, okay, landfill sites, okay, and bring samples, do some drilling, okay. So there are a lot of options to explore, and tomorrow's class I will be showing about some of the projects which our environmental engineering group is working on to excite you on what are the things beyond, okay, classroom lectures and calculations, what you do, what we do things in the field. I want to show you some of the projects what we are doing, okay. All right, thank you.